Hello, in this video, I'll explain the concept of region. First, let's explore the concept of a region. A region is not just a collection of numbers or points. It is a set that includes all the points surrounding a specific point or number. Therefore, when defining a region, it is important to consider both the property of a set and the unique characteristic of the region. In this video, we'll focus on defining concepts of regions through the interface of a programming language Go rather than through set theoretic axioms. First, let's define the set interface, which represents a set as I explained earlier. The set interface is defined using a type parameter, and this type parameter must be of the element type. Next, let's define the region interface. The interface includes a set interface with a point type as a parameter and has a method called corner and length. It's important to clearly define the meaning of these methods. For example, corner method returns the corner of a rectangular region. This return value is expressed as a vector. The length method returns the length along with axis as an array of real numbers. This method isn't limited to representing only rectangular region. By utilizing the contains method provided by set interface, you can specify only a desired portion of a region as a region. For example, let's assume we're implementing a one-dimensional region such as interval. An interval is defined by starting point and endpoint, which we call this as an interval. This interval must have contains method, which checks if dimension of the input point is 1 and whether it lies within the interval. The corner method indicates the start point of the interval and returns it as a vector. The length method returns the length of an interval, but it returns as a slice to represent general lengths in an n-dimensional space. Now, let's implement a two-dimensional region. In this case, we'll handle a rectangular region, but a rectangular region doesn't necessarily mean only two-dimensional. For example, in 3 dimensions, it could be a cube. This region can also check if a point lies within it using the contains method. The corner method returns the smallest point within the region, and the length method returns the length along each dimension. Now, let's look at how to divide region, which is a practical way to apply the concept of region. Dividing a region is very useful when drawing graphs or calculating integrals. For example, consider how to divide a rectangular region into several smaller regions. First, let's assume the large rectangle is the entire region with its corner located on a specific position. If we divide each axis into n segments, we create n+1 grid points along each axis, resulting in n+1 square grid points in 2 dimensions. Let's first look at the indexing of these grid points. Set the axis of the corner to be 0, 0. When each dimension is divided into n segments, indices from 0 to n are generated. The indices of these divided grid points are arranged in lexicographical order. In other words, the first index increases first, followed by the second index. Now, let's consider coordinates of these grid points. For this, we'll need basis method we mentioned earlier. The basis method returns a list of basis vector and will move the base point by a certain amount in the direction of each basis vector to obtain the grid points. Remember that the base vectors are assumed to be unit vectors, so their length must be reduced by 1/n of the total length. Let's now implement the division. The mesh function takes the region type variable reg and the number of subdivisions per dimension n sub as inputs. It returns the coordinate of the subdivided points as a slice. These coordinates are returned as vector types. The first step is to find the reference point for the division. This can be found using the corner method of the region. Next, we find the basis vector using basis method of the vector. One important thing to check here is whether the dimension of the region and vectors are the same. If they differ, an error will occur during the execution of the code, so it's important to check this in advance. Next, the length of the basis vector needs to be reduced. To do this, we set a rational number equal to 1/n. Then reduce the length of each basis vector by 1/n of the length of each dimension. These reduced basis vectors are then passed to the subinc function, which moves the reference point accordingly and records the result in a slice to be returned. The subinc function returns the vectors in sequence that move the reference point according to the order of the grid point. Now let's look at the subinc function. The function works as follows. The input variables are a slice of vectors determining the position of grid points and a natural number indicating the number of movement. This function returns a vector that points to the grid points in the form of a channel. The subinc function is called recursively, moving the first vector n times, removing it from the list, and then adding the remaining vectors to the newly created vectors. So far, we've explored the concept of regions and how to apply them. In the next video, we'll cover how to draw graphs. Thank you.